Alright guys, we're looking at solving quadratics, kind of extending what we already know. So we're going to start off with a couple examples here, hopefully that are pretty familiar to you. And these are kind of the three types of problems we've seen so far. So when we're solving these quadratics, what we mean by that is find the x-intercepts. That's what we're trying to do. Or the roots. We call those roots of the equation. So on a graph, this is where these parabolas are going to cross over the x-axis. So the first thing that we're going to do is we're going to set it equal to 0 because we know the y value is 0, so we plug in 0 for y. So let's go ahead and do that. Second thing we're going to do is we're going to look for a greatest common factor, and between these three terms it looks like there is no greatest common factor, so my next step then is to try to break it up into a couple different factors. So this one looks like a nice easy one. I don't have a number in front, so I'm just looking at x times x. And then I look at factors of the c value here. So it looks like it's just 1 and 2. And that's nice and easy because I can get a sum of 3 if I just plug in a 1 and 2 here. Both are positive. And then we use that zero product property. I've got two things multiplied that give me 0, so one or the other has to be 0. So I just split them up like this and then go through and solve for x. So here I've got one of my answers. X can be -1 or x is -2. So that's the first type, is factorable, nice easy factorable. The second type is when you've got this number in front. It's the same process. We want to find the x-intercept, so we plug in 0 for y, so we set this thing equal to 0. And then we want to look for a greatest common factor between this term, and this term. And it looks like I could pull a 2 out of there, so 0 equals 2 times whatever's left over on the inside. And what's left on the inside is actually what we had over here, so we're just going to factor what's on the inside. We already did that in the first problem. That factors to x plus 1 times the quantity x plus 2. That's all equal to 0, so we split it up using that zero product property. 2 equals 0 doesn't make any sense. It's not one of our solutions, but x plus 1 could be 0, or x plus 2 could be 0, and then go through and solve, and we get obviously the same solutions that we did for the first one. So -1 or -2. So that's the second type where you can pull the greatest common factor out first and then factor it. The third type of problem that we've seen is one of these quadratics where it's got a number in front, but there is no greatest common factor. I'm still finding x-intercepts, so I'm still going to set it equal to 0. Like we just said, there's no greatest common factor, so I've got to find a way to factor this into two binomials. I'm looking at this first term here, and it looks like it's got to be a 2x and an x. My last term is just a 1, so it's got to be a 1 and a 1. And I've got to figure out my signs here. So I need to be left over with a -1 when I add my inner and my outer. So if I need a -1, then my outer, when it's multiplied, I would get a -2 and a +1. And that would leave me with this expression up here if we were to expand it and check it. So there's my factored form. Again, zero product property, we're going to split this up because I've got two things multiplied that are equal to 0, so one or the other has to be 0. And we can get our solutions by solving this. So -1 minus 1, 2x is equal to -1. X is then -1/2 when I divide by 2 and solve. So there's one of my solutions. The other solution, nice and easy. Just add 1 to both sides, and there's my other solution. So these are the three types that we've seen. One that's factorable with no greatest common factor, a greatest common factor that is factorable on the inside once you pull that out the front, and then one of them that has a number in front of the x squared term that doesn't have a greatest common factor. We can still factor sometimes. So what we want to do is we want to move forward and kind of add another tool that we can use when dealing with these things. And that other tool is called the quadratic formula. And so what this does is this formula allows us still to solve and find x-intercepts. We're still finding x-intercepts, or where that thing crosses over the graph. But it turns out that if we use this formula based on the coefficients of these terms up in our standard form quadratic, we can find the x-intercepts. And where this is nice is when you have non-factorable x-intercepts, or non-factorable quadratics, I should say, but it also works for factorable quadratics. So we're going to look at the ones that we just looked at. So this was the first one that we just looked at, and we're going to solve this using the quadratic formula. So again, the form is ax squared plus bx plus c, and we just pull our numbers out of this standard form quadratic and we plug it into this formula, and it should spit out our roots. We already know from our work before that our roots are -1 and -2, so those are the answers that we should come up with. So let's go through this process using the quadratic formula. First, I see here a is 1, b is 3, and c is 2, so we just plug in. So here we've got x equals the opposite of the b term that I see. So the opposite of the b term is -3, and it's plus or minus, and this is where our two answers come from. The square root of this whole thing. So b squared, that's 3 squared, minus 4 times the a term, here is 1, and the c term is that number that's hanging out there by itself, which is 2, and it's all over 2 times whatever a is, so 2 times 1. To finish off this quadratic formula, we just simplify this expression. So because we're simplifying, we want to work inside here first. So we've got -3 plus or minus the square root of 9 minus 4 times 1 is 4 times 2 is 8 over 2. Simplify it, and we get -3 plus or minus the square root of 1 is just 1 over 2. And this is where our two different answers come in. So I get, my first answer is x equals -3 plus 1 over 2. My other answer is x equals -3 minus 1 over 2. When we go through and we simplify that, simplify the top first. -3 plus 1 is -2 divided by 2. And we get our x equals -1, which is one of our answers from before. Or x equals, and again simplify the top first, -3 minus 1 is a -4, divided by 2 is -2, and there's our other answer. So again, these are the exact same answers. This is the same problem, just done in a different way. This is this problem right here. We got the two exact same answers. We can actually do it in one way or the other. They both work, either quadratic formula or factoring like we originally did. So let's check out another problem here. We're going to look at the third problem. So this is one of those ones that's a little bit harder to factor. And if you're not good at factoring these, this quadratic formula is really nice if you can remember what it is. So let's go ahead and identify what our coefficients are. Our a is 2. Our b here is -1. And that comes right from here. And our c comes from that number that's hanging out by itself, and that's also -1. So we're going to find the x-intercepts here, or the roots, which is the same thing as the x-intercepts, by using the quadratic formula. So x equals, and we just plug in our numbers. The opposite of what I see up here, I see b is -1, so that turns into a +1. Plus or minus the square root of b squared is -1, -1 squared, minus 4 times a is 2, that's from here, and c is -1. All of that stuff over 2a, which is 2 times 2. So we go through and we simplify. We should be able to find the same roots, just like we did using that factoring. Simplify everything on the inside of the square root. So this is going to be 1 minus 4 times 2 is 8 times another -1. So negative, 2 negatives, turns it into a positive. That's plus 8 over 4. Simplify a little bit further, and we get 1 plus or minus. This is the square root of 9, which we know is just 3. Over 4. So this is going to give us our two answers. So our two answers are x equals 1 plus 3 over 4, or x equals 1 minus 3 over 4. Here we're going to have 4 over 4, so that's 1. Or x equals 1 minus 3 is negative 2 over 4 is negative 1/2. And again, hopefully you see this is the same exact answer that we got before. So just to reiterate, when we're finding x-intercepts or roots for these quadratics, you now have two different tools if it's factorable. But I mentioned it before, if we end up with a quadratic that's not factorable, like this one right here is not factorable, I'm looking for a difference of 1 here. And if I look at the factors of 4, I've got 1 and 4 and 2 and 2, and there's no way that I can get a difference of 1 there. So this quadratic is not factorable. The only way that we can solve this thing, then, as of right now, is to use this quadratic formula. So let's go ahead and use the quadratic formula. Here's my a term. My a is 1. That's the number in front of the squared term. My b is negative 1. And my c is going to be negative 4. So last example here, we'll use this quadratic formula, and we can actually solve these. We can find the roots, or where it crosses that x-axis, using this quadratic formula. So just plug in what you know. You know that b is negative 1, so I plug in the opposite of that, which is positive 1. Plus or minus, b squared is going to be negative 1 times negative 1 is 1, minus 4 times a, which is 1. c is negative 4. Over 2a, or 2 times 1. So we want to go ahead and simplify. X is equal to 1 plus or minus. Let's simplify what's inside the square root first. So this is going to be 1 minus 4 times 1 is a negative 4, times another negative turns it back to positive, and we end up with a positive 16 over 2. Let's split it up here, simplify inside, and then we can split it up. So 1 plus or minus the square root of 17, which is a little over 4. So our two answers are going to look like this: 1 plus the square root of 17 over 2, or x equals 1 minus the square root of 17 over 2. So if we want an exact answer, we would just stop there. This is our exact answer. If you want a decimal approximation, you can do that. You can plug it into your calculator. Just be careful when you plug it into your calculator. This is going to be a rounded answer. So the first one, after I plug it into my calculator, I get about 2.56. So there's one of my roots is around 2.56, a little over 2.5. My other root, when I plug it into the calculator, is going to be about negative 1.56. So there are my two answers. So again, just a step back, we've got this quadratic formula. It works whether these things are factorable or not. But it's really useful when these things aren't factorable, especially on even on harder ones, harder factoring problems. We can use this quadratic formula and find our answers pretty easily.